working a few more problems on your page 2 of your note packet. We're going to start with letter F now. This one too involves a few different properties of exponents. And again, one of the things that you can do is to get rid of that outside exponent first before trying to simplify here. You need to take care of the power on the outside first. So we're going to raise everybody inside to the fourth power, which includes the negative sign. So it's -2, still in parentheses, to the fourth power. And then when you raise a power to a power, remember we're multiplying those together. And then p to the -1 times 4. All right, now the power only goes to what was inside parentheses here. The 4 doesn't come down here and do anything with these variables or the number. They're not in parentheses. So we're just going to rewrite that as 3k to the -5 and p to the 7. And we can simplify the number part here. -2 to the fourth power is going to give me a positive 16. That's taking -2 times -2 times -2 times -2. And the 3 down below. Now these don't simplify, so we're just going to leave it as 16/3 for right now. The k to the 12th has a positive exponent. We're going to leave it where it is. We want our final answers to have positive exponents in it, so we're going to leave the positive 12, the k to the positive 12 up in the numerator. The p to the -4, though, that has a negative exponent in it. We're going to move that across the line, and when it drops down below the line, it's going to change the sign of the exponent. So I'm just going to move it down to the denominator. Now it's p to the +4. The k to the -5 down below, when I cross the line with that term, it's going to go and change the power to the opposite. So it's going to be k to the +5 now. And p to the 7 is positive where it stands. So we're going to leave the positive exponent where it is, keep it as p to the 7th here. If I had moved that across the line, that would have become p to the -7. It automatically toggles it to the opposite sign. Since we want positive exponents, we're going to leave the ones that had positive exponents where they were and only swap the ones that had negative exponents around. Now I can total them up. Because the k's are on the same side, we're going to use the property that says when I multiply like bases, I add the exponents. So I have what, k to the 17. And on the bottom, again, multiply like bases, add the exponents, p to the 11. And there's no more simplifying here because I can't cancel anything here. The k and the p have different bases, so I won't be able to go any further with that. Taking a look at the next one here, again, the power 3 is only responsible for the numbers and variables up in the numerator. So again, the -5 in parentheses being raised to the 3rd power, a to the 3rd, b to the 3rd, and down below 10 and a. Simplifying here, -5 times -5 times -5 again is going to be a -125. Now you can use your calculator, but again, make sure you're putting parentheses around. We have a to the 3rd, b to the 3rd, and 10 over a. Now, these are divisible both by the number 5. 5 will go into -125, -25 times, and 5 will divide into 10 twice. And I can't reduce that fraction down any further. I have all positive exponents. This is a to the 1. So I'm not having to move them across the line. That would change the sign and make them negative exponents. I want them to stay positive, but I have 3 of those a's on top being multiplied together, and I have 1 on the bottom. So this is where I can go ahead and use my quotient rule and subtract. Go to the side of the bigger number here. So it's a squared on top and b cubed on top. This is as far as you can go with this problem. For h, I have no powers on the outside to raise to, so I'm going to go ahead and start simplifying the number parts first. 15 divided by 5. Well, 5 goes into 5 once. I could put a 1 down here, but I don't have to. And 15 goes in, or 5 goes into 15 rather, 3 times. Now I take a look at my powers here. That's a positive exponent, so it's going to stay where it is. X is x to the 1. It has a positive exponent. It's going to stay where it is. But y to the negative 9, I'm going to drop that down below the line. And it's going to become y to the positive 9. Y to the 11th is going to stay on the bottom. Now it doesn't matter if I have y to the 11th here and y to the 9th at the last position here, because ultimately I'm going to combine those. So I have 3. And now I think about this. I have 6 x's across the top. I have 1 across the bottom. So if I cancel or subtract, I end up with 5 of them on top. These are on the same side of the line, so I'm going to total them up. I have 9 y's, and then I have 11 more y's. So I'll total, when I add those up, I end up with, what, 20 of them on the bottom. For our last 2, again, I've got to take care of this outside power. Everything inside the parenthesis will be raised to the 3rd power. So negative 2 to the 3rd power, a to the 3rd, along with 3 to the 3rd power, and then b to the 3rd. So in simplifying this, negative 2 to the 3rd is negative 8, a to the positive 3 exponent, 3 to the 3rd, 27, that's 3 times 3 times 3, and then b to the 3rd. Notice my exponents are both positive, and they're different bases, so I can't do anything more to these. This is simplified as far as I can go. There's no number that'll divide into both 8 and into 27, so the fraction is reduced as well. Keep in mind, that's a negative 8. That's not a negative exponent, so the number negative 8 stays where it is. In fact, the power on 8 is the number positive 1, same for 27. Both of their powers are positive, so we're not moving those terms. For our last one, everything raised to the negative 3 power. So on the inside, when I raise a power to a power, we end up multiplying the powers together. And q is really to the 1 times negative 3 power, which is negative 3. R to the, and then again, negative 3 times negative 3, r to the 9th. I have a positive exponent here, so it's going to stay put. The negative 3 power is going to drop that term down to the denominator. And the r to the 9 is staying put because its exponent is positive. And now we've got a fraction that's reduced because none of these have the same bases, so we can't do anything more to this problem. So that would be your final answer.